Hi, my name is Tejesh Achari. My roll number is 20951A04M0 and I'm from ACD section. And my topic is how to demonstrate concurrent sorts by tonic sorter. So, by tonic sort does n log square n comparisons. The number of comparisons done by bitonic sort are more than popular sorting algorithms like merge sort. So n log n comparisons, but bitonic sort is better for parallel implementation because we always compare elements in predefined sequence, and the sequence of comparison doesn't depend on data. Therefore, it is suitable for implementation in hardware and parallel processor array. Bitonic sort must be done if number of elements to sort are 2 power n. The procedure of bitonic sequence fails if the number of elements are not in the aforementioned quantity precisely. A sequence is called bitonic if it is first increasing, then decreasing. In other words, an array 0 n minus I is bitonic if there exists an index I where 0 is lesser than or equal to I, which is lesser than or equal to n minus 1, such that x theta is lesser than or equal to x1, and it goes on until it's less than or equal to xi, and xi is greater than or equal to xi plus 1, and it goes on where it is greater than or equal to xn minus 1. A sequence sorted in increasing order is considered bitonic, with the decreasing part as empty. Similarly, decreasing order sequence is considered bitonic, with the increasing part as empty. A rotation of bitonic sequence is also bitonic. How to form a bitonic sequence from a random input? We start by forming 4 element bitonic sequences from consecutive 2 element sequence. Consider 4 element in sequence XO, X1, X2, X3. We sort XO and X1 in ascending order and X2 and X3 in descending order. We then concentrate the two pairs to form a 4 element bitonic sequence. Next, we take two 4 element bitonic sequences sorting one in ascending order, the other in descending order, using the bitonic sort which we will discuss below, and so on until we obtain the bitonic sequence. Example, convert the following sequence to bitonic sequence 37486215. Step 1. Consider each two consecutive elements as bitonic sequence and apply bitonic sort on each two pair elements. In next step, take two 4 element bitonic sequences and so on. A B equals minimum of A comma B, maximum of A comma B. A B equals maximum of A comma B, minimum of A comma B. So you can see the bitonic sequence down: 37486215, 3784 where 4 and 8 are interchanged, and 2 and 6 are interchanged, and 5 and 1 are interchanged. It mainly involves two steps. Forming a bitonic sequence discussed above in detail. After this step, we reach the fourth stage in below diagram, that is, the array becomes 34786 creating one sorted sequence from bitonic sequence. After first step, first half is sorted in increasing order and second half in decreasing order. We compare first element of first half with the first element of second half, then second element of first half with the second element of second, and so on. We exchange elements if an element of first half is smaller. After above compare and exchange steps, we get two bitonic sequences in array. In the fifth stage, we have 3, 4, 2, 1, 6, 5, 7, 8. If we take a closer look at the elements, we can notice that there are two Botonic sequences of length n by 2, such that all the elements in the first Botonic sequence 3421 are smaller than all the elements of second Botonic sequence 6578. We repeat the same process within two Botonic sequences and we get four Botonic sequences of length n by 4, such that all elements of leftmost Botonic sequence are smaller and all elements of rightmost. See, if we repeat this C6 stage in below diagram arises 2, 1, 3, 4, 6, 5, 7, 8. If we repeat this process one more time, we get 8 Botonic sequences of size n by 8, which is 1. Since all these Botonic sequences are sorted and every Botonic sequence has one element, we get the sorted array. Analysis of Botonic sort. To form a sorted sequence of length n from two sorted sequences of length n by 2, log n comparisons are required. For example, log 8 equals 3 when sequence size. Therefore, the number of comparisons Tn of the entire sorting is given by Tn equals log n plus Tn by 2. The solution of this recurrence equation is Tn equals log n plus log n minus 1 plus log n minus 2 plus log plus 1 equals log n plus 1 by 2, as each stage of the sorting network consists of n by 2 comparators. Therefore, total n log square n comparators. So, we learned about Botonic sorting and how to do it and how to form a Botonic sequence from a random input and the whole steps for it. And we even analyzed a Botonic sort and then we come to the conclusion. Thank you.